So, in fact, there are few questions that I have received. The questions are mostly non-technical in nature. The first question that I have received is what are the most prominent research avenue in deep learning? You find that deep learning is nothing but a more specialized form of machine learning. So, wherever you have applications in machine learning, deep learning can also be applied in the same area. In addition, when you go to later part of the courses, you will find that when we talk about deep learning, there are other advanced research topics which are normally not covered under traditional machine learning algorithms or the techniques. So, those are the techniques or the topics under deep learning. Say for example, when you go for generative model, you can also synthesize images or synthesize signals using different deep learning algorithms. So, coming to your identification, recognition, synthesis, face recognition, authentication. So, these are the different areas in which the machine learning as well as deep learning, both of them can be applied. And it is expected that instead of the traditional machine learning approaches, if I use deep learning approaches, in that case the accuracy may be much better, or in general it is much better than the accuracy that you get in case of traditional machine learning algorithms. So, the application domain of the research domain is quite large. You have to identify the research domain, and then you have to think of that how deep learning techniques can be applied in those research domains. So, that is one. Next is what is the role of general image based transfer learning on medical images. Also, how to design specific network or architectures for medical image classification. Now, when it comes to classification problem, you see that how do we go for classification? I have covered in initial few lectures that when you go for classification using the traditional machine learning techniques, in any classification there are two different stages. In the first stage, what you do is you find out the features or the feature vectors using some pre-processing techniques or some low level processing techniques, and then comes your classifier. So, in case of classifier, you feed those features or the feature vectors to the classifier, and using those feature vectors from the known samples, the classifiers are trained, and once the classifiers are trained to classify different signals, then for unknown signals you capture the same set of features or the feature vectors, feed it to the classifier, and the classifier classifies that signal. What you do in case of deep learning is that pre-processing stage, which is used in traditional machine learning techniques for feature extraction or feature vector extraction, that task is also given to the deep learning algorithms or the deep neural network architecture. So, that your entire classification job, given the input signal, raw input signal, and the final classification task, this is an end to end solution. I do not have to have a separate module for performing the pre-processing for feature extraction techniques. This is also done by the deep neural network itself. So, if you remember the architecture of the deep neural network, which possibly has not been covered fully, the initial few layers at the beginning, they are actually convolution layers, and the purpose of these convolution layers along with pooling and other things is basically to extract the feature vectors. And after all these convolution layers, your final layer in this deep network architecture is actually a fully connected layer or the classification layer. So, when you consider end to end, the initial layers actually extract the feature vectors or the features which are fed to the fully connected neural network, which is nothing but equivalent to multilayer perceptron, which is actually the classifier. So, you are training it end to end. And when it comes for medical image classification, again here the classification is based on the feature vectors. So, what actually comes into picture is what are the training samples or the training feature, training images that you consider, whether it comes from the medical domain or any other domain. So, coming to your classification task or the training task, it is the input signal that you are providing and the training algorithm that you are using. Okay. And training algorithm, there is nothing new. It is the same backpropagation algorithm which is used across all problem domains. So, what actually differs is your training data and your class identifications. That is the basic difference, right. So, otherwise whether you are using it for medical image classification or using it for any other type of classification purpose of any other images, it mostly remains the same. The next question that I have received is to answer the assignment questions correctly, which book should I follow and in which book I will get the details of your lecture. On deep learning, there is a famous book by Ian Goodfellow. So, you can have an access to that book. But before you go through the book of on deep learning by Ian Goodfellow and others, I will suggest that you go through some book on pattern recognition or traditional machine learning, because pattern recognition techniques and machine learning techniques are actually same, only the name is different. So, there is a very good book for pattern recognition, which is Pattern Recognition and Image Analysis by Duda, Hart and Stork. It is a pretty old book and a very good book. I mean, it deals with the theory as well as the practical aspects. So, before you go through the book on deep learning by Ian Goodfellow, you should go through this book once. That will make the other things simpler. The next question that I have is what are the still research areas in terms of sentiment analysis which can be covered by deep learning? Okay, coming to sentiment analysis, you find that this sentiment is not only a spatial signal, it is a spatio-temporal signal. That means, I have the video sequences of a person. So, considering every frame, it becomes a spatial signal, and when you consider sequence of frames, it is a temporal signal. So, it is basically a spatio-temporal signal. And when you use these deep learning architectures for such sentiment analysis or sentiment recognition, sentiment classification, the way you should use these signals is to consider a sort of video volumes. That means, to capture the temporal effect or the temporal variation of the information, you take a number of frames together, say n number of frames, and that makes a video volume, and that n number of frames you should feed to the neural architecture or the deep learning architecture. So, that is how you can analyze the sentiment from facial expressions or face video sequence. The next one that I have is, it is not really a question, but a comment. For learning any type of programming, we must have grip on concepts of basics. So, no questions, I just want to listen to him. It is a good comment, right? Thank you very much. I do not know who has made this comment. The next one, I am an student of BTech third year. So, the content seems to be very tough for me. Can you please suggest me a book from which I can understand the concepts deeply? So, on deep learning, I have already told you the book. The name of the book is, title of the book is Deep Learning. It is by Ian Goodfellow, and who are the other three? There are three authors. So, if you give a search on Deep Learning by Ian Goodfellow, you will get all the details of that particular book. Okay. And possibly the soft copy is also available in public domain. You can even download that book from public domain, it is possible. And because you are an undergraduate student and particularly third year student, I will suggest that before going through this book on deep learning, as I said, you try to go through the book on pattern recognition and image analysis by Duda, Hart and Stork. That will make your life simpler. You will find it much easier when you go through the book on deep learning, because deep learning is nothing but further specialization of machine learning or the pattern recognition techniques. The second question, I could not submit my fourth and fifth assignment because of circumstances. What can I do for that? Is there any chance that I can submit that assignment? I don't know. I mean, this is a question. I think you be in touch with the admins. Okay, so if that is permitted, you can do. The next one is, will I get the nano degree? I don't know what is this nano degree. You have any idea? But that is a micro specialization. For every course they get a certificate. And what is a nano degree? Is there any concept of nano degree?
Many courses in this domain, like in deep learning, they have done many courses, then they can get a nano degree.
Oh, is it called nano degree?
Some website hosts this Coursera.
Okay. So, fine. So, in that case, as I understand that this nano degree cannot be based on a single course. For every individual courses that you attend and you clear successfully, you will get certificates, and possibly if you cover a number of courses pertaining to a particular stream, you may get a degree. I am not sure if it is called a nano degree or not. The second one is, yeah, again it is a comment. Your lecture videos are extremely organized, but I would like you to handle programming of the concepts that you have covered in theory. Actually, initially when I planned this course, I had that in mind, that I will have a mixture of theory along with programming, but the course content is so large that I had to drop the idea of the programming later on. Yeah, maybe in future I will think of another one where this theory will be a prerequisite and we can have some other course specifically targeting on programming, but definitely that cannot be possible in this one. Okay, then the next questions I have is, how important is knowing the derivations of the formulae used in various scenarios like loss functions, etc. Is just knowing the formulae sufficient? Okay, right. Here I will suggest that if you simply try to memorize the formulae, you do not know how those formulas come or how to derive them, or what is the basic principle from which those formulae have come, right. So, being engineers or being scientists, for exam purpose, okay, possibly knowing the formula is sufficient, but for your application and particularly if you are going to research domain, knowing the principle how those formulas are coming, how those are derived, that is very, very important. So, you may not memorize, but once you know the principle, once you know the concept, you should be able to derive. Okay, but for exam purpose, that may not be required. For exam purpose, memorizing the formulae may be sufficient. The next question is, can we use deep learning to predict outcomes for which we have only 500 to 1000 records. Is it necessary for deep learning to have large data? Yeah, we have already covered in the course that deep learning algorithms are data hungry. That means I have to have large volume of data, so that the structure in the data is understood by the network, right. So, having large number of data or huge data is always beneficial for deep learning algorithms. So, when you have limited data, then there are concepts of data augmentation or data replication. That means, you can synthesize data sets using the machine learning algorithm itself, so that apparently you can generate huge volume of data which can be used for training of the deep neural network architecture. But availability of huge amount of data is very, very important. How do we handle requirement for matching two curves, whether they are from the same source or not, where there are very few matching available? Right, I did not really understand that curves coming from two different sources, but if you want to match two different curves, I believe use of deep learning is not necessary. Simply having cross correlation function, computing cross correlation between the two curves will give you the result. Kindly suggest some algorithm to, that is what I just said, that comparing two curves, you do not need deep learning or machine learning algorithms. Computing the cross correlation function or cross correlation value between the two curves is sufficient to find out the similarity between the two curves. Okay. So, those are the questions which had come before. How can decide which kind of autoencoder is suitable for a given problem statement? If we have image, can with fully convolutional autoencoders, if we have unstructured data, we can use MLP. Okay. Okay. So, the question was, how can we decide which kind of autoencoder is suitable for a given problem statement? Right. So, you understand the use of autoencoder, right? Autoencoders, when you think of the autoencoder architecture, there are two different components. One is the encoder part, other one is the decoder part. So, when you train an autoencoder, at the output of the decoder we expect that whatever we are feeding at the input of the encoder, the same should be reproduced at the output of the decoder. And you train this autoencoder in such a way that the error between the input and the reconstructed output, that is minimized. So, in effect, what autoencoder does is, the autoencoder or the encoder part actually codes the input signal in a reduced dimension or a reduced dimensional space, which can further be used for classification purpose. Decoder in an autoencoder is not really used. What is used is the encoder part. So, if we have an image, we can use the convolutional autoencoder, because as we said that the convolutional networks tries to find out the features, it extracts the features or the feature vectors from the input images. So, if I use a convolutional autoencoder, the convolutional networks will actually give the feature vector at the output of the encoder. Whereas, if you have unstructured data, then you can use multilayer perceptron. Unstructured, by unstructured what I mean is the data which are not images, because images are actually structured data you always have in the form of a 2-dimensional array or 2-dimensional matrix. The next question that I have is, please explain basic of regression by SVM or support vector machine. Right. Okay. Given this short time, it may not be possible to explain the regression by support vector machine, but for that I will redirect you to another NPTEL course of mine, which is the course on pattern recognition. Okay. So, there you will get the details of it. Okay. Okay, then the next one is, as for deep network large data set is required, is there a way by which we can level such data set automatically? Again, part of this answer will be in the pattern recognition course, the same online video lecture that we will have. And to deal with this large data, you find that the initial layers of the deep neural network, like mostly convolutional neural network, they tries to extract the features where the features are usually domain independent or the image independent. So, some layer finds out the edges, some layers finds out the corners, but when you go to the upper layers, those are fully connected layers, there actually the domain knowledge comes into picture. So, transfer learning is a way in which the requirement of huge data may be avoided. And the other one is, you can go for a sort of semi-supervised learning, or I will call it a hybrid learning, where you can have a small set of data which are actually annotated, and then you can go for a sort of grouping of the other data which are not annotated or labeled. And when you have these groups of data, each group of data can have the same annotation or the same label. So, this is another way in which you can generate, even if you have large amount of data, maybe you can avoid the problem of labeling each and every data manually. And also, as I said, that if you have limited amount of data, just answering one of the previous questions, that you can make use of the data augmentation techniques to generate huge amount of data. Right. Any other question? Kindly explain linear classifier problems. Again, similarity between data science and deep learning. Few more examples of multiclass problem. How works autoencoder? I think autoencoder I have already told that what is the purpose of autoencoder and how the autoencoder is used. Examples of multiclass problem. Okay. So, some of the examples that we have considered during the lecture is say digit classification in MNIST database. This is one problem, a classical problem which which almost everyone starting working on classification or machine learning they consider. The other one that also we have considered is image net classification. Okay. So, these are the problems that we have referred to while giving the lectures on deep learning. But in addition, you can have examples from your day-to-day examples. Say for example, when I go for biometric authentication, say face recognition problem, right. There might be some areas in any organization which is secured, and we do not want each and every person or each and every visitor should have access to that particular area. So, there we can have a biometric authentication or face recognition system, where the visitor has to stand in front of the camera. The camera will take the face image and that has to be recognized as whether the person is to be allowed in that area or the person is not to be allowed in that area. So, that is one practical example that you can have. The other practical example can be say your fingerprint recognition, again biometric authentication systems, right. And now I think almost all of you have experienced such a kind of application. For example, when you go for opening your bank account these days, right, the first thing that you have to do is you have to give your Aadhaar number and then you have to give your fingerprint. So, your fingerprint has to be authenticated against your Aadhaar number. Okay. So, this is another one which is fingerprint based identification or authentication. This is obviously another example of multi-class problem, because we have a large number of people and for each of them we have fingerprints. So, there are many such examples, right. Even in medical domain, from different test results, say for example, ECG, EKG, you have MRI, you have CT scan. From those different images, the doctor needs to identify the disease. That is also a multi-class classification problem. So, the problems are many. Wherever you think you can find out a problem. The next comes similarity between data science and deep learning. So, I will put it this way: deep learning is a subset of data science. Data science is much more broader, and some of the problems of data science, for example, data mining or classification, recognition. Say for example, I can think of a problem in given a textual data in the form of large number of images, we can go for say keyword search or some word spotting. So, I want to give a search word as a search key, and I want to find out that in that particular textual data where that particular word appears, right. So, the next problem can be a deep learning problem, right, and this is part of the data science. So, data science is a much bigger problem, and certain problems of data science can be addressed through deep learning, right. Now, coming to explaining linear classifier problems. Okay, so, I will put it this way. So, what you are doing in machine learning or in deep learning, as I said that deep learning is nothing but an advanced version of machine learning. You are trying to classify or you are trying to recognize certain objects or certain concepts, and when I say that I want to classify or I want to recognize, then it is obvious that I have some pre-knowledge of those objects or those concepts, and given an unknown input, I want to classify or I want to associate that unknown with one of the objects which are known to me. So, the objects which are known to me, those are actually known during the training phase, right, and during testing phase or during application, you are going for classification or recognition based on the knowledge that you have already acquired. So, in a simple term, I can put it this way: suppose I have a feature vector which is a two-dimensional feature vector. So, simply think of an xy plane where and I have maybe for simplicity a two-class problem. So, because I am assuming that my feature vectors are two-dimensional feature vectors. So, again when you think of in terms of your deep neural network, my original input data may have dimension which is much more than 2, but that data is passing through a number of layers which are actually convolution layers. And I will put it this way, that the last convolution layer outputs only 2 signals, right. That makes your feature vector a two-dimensional feature vector. And these 2 which are coming from the convolution neural networks are fed to the fully connected neural network. So, the input to the fully connected neural network is actually 2 nodes, and output of those 2 nodes and output of the fully connected neural network gives you the classification. Now, when I think of just a two-class problem, so I have a feature space which is a two-dimensional space, the xy plane, and I have 2 different classes. So, objects or the data coming from 2 different classes, they have all two-dimensional feature vectors. So, every feature vector can be represented by a point in that two-dimensional feature space. So, it is quite expected that the feature vectors coming from one class will form one point cloud, and the feature vectors coming from another class will form another point cloud. Now, when you go for classification, given these 2 point clouds, say one of them I call as C1 and other one I call as C2. Now, if it is possible that I can draw a straight line between these 2 point clouds C1 and C2, so that no point belonging to C1 falls on a side which actually belongs to C2. At the same time, no point belonging to C2 or no feature vector belonging to C2 falls on the side which belongs to C1. So, what this straight line does is, it actually divides your feature space into 2 half spaces, and one of the half space you are allotting to C1 and the other half space you are allotting to C2. So, this is what is a linear classification problem, because I can have a linear boundary between 2 different classes. Now, when an unknown feature vector comes for classification, if I find that that feature vector falls on the side of C2, I will classify that as class 2. If it falls on C1 on the side belonging to C1, I classified that as class C1. So, this is for a 2-class problem. I can have it for multi-class problem. So, in that case, instead of dividing into just 2 half spaces, it is possible that for every class or for every pair of classes, I should be able to draw a straight line, so that through a set of straight lines, I can have separation between every pair of classes. So, those are what are linear classifiers, right. As we have discussed in the lectures, that when I have a multi-class problem, these linear classifiers can be implemented in the form of a linear machine. Then we have also subsequently gone to that these linear machines are actually the stepping stones of your deep neural network or deep learning techniques. Yeah, this is an interesting question. Will this course be helpful for applying for jobs? In which form we can apply? Okay, I will just answer it in a slightly different way. For all the courses on machine learning, forget about deep learning. The number of students who register or who want to do such courses of machine learning or deep learning that exceeds the average strength of any other class. And in fact, some cases the class strength goes beyond 500. So, that effectively tells you that what is the demand of machine learning or deep learning courses in industry. In fact, most of the software companies these days, you talk about Google, you talk about Microsoft, Facebook, all these IT companies, they have huge requirement of manpower in the areas of machine learning or in the areas of deep learning, right. So, there is huge job opportunity, but at the same time you also have to keep in mind that most of the students, a large number of students are actually these courses. So, there is huge job opportunity, at the same time there is huge supply of manpower. So, you have to be always competitive with respect to others. Deep learning algorithms can we use in IoT or AI? Few examples. Yeah. So, these days AI and machine learning, they are used almost interchangeably. So, when we talk about machine learning, people think of it as an AI, right. So, AI and deep learning is very, very interrelated. I should not really try to differentiate between AI and machine learning, because machine learning is nothing but an AI technique. Coming to its application on IoT, yes, definitely there is a large number of applications, because what is IoT after all? It is integration of all different types of sensors that we can have. It is Internet of Things. So, anything that can be networked, whether it is temperature profile of certain region, whether it is the pollution profile, your water pipeline, the power grid, anything that you can think of, that can be part of an IoT. And whenever you have an IoT, say for a simple example, that I want to find out that from power grids, that what is the power use pattern over on a particular day or over a particular season, and using that whether I am able to predict what will be the power requirement in future. So, that accordingly the grid corporation or the thermal power or any other power sectors, they can plan how to deploy the generators or when which generator has to be made on. So, definitely deep learning or machine learning has got applications in IoT. Only thing is you have to think of that through IoT you get huge amount of data, right, large number of channels, large number of modalities, but you have to identify the problem domain where this deep learning has to be applied. Definitely it is applicable in case of IoT. Basic idea about the deep learning. Okay. So, whether you talk about deep learning or whether you talk about machine learning, when you talk about any of these learnings, deep or machine, because deep learning is nothing but an advanced version of machine learning, what we are trying to do is we are trying to impart a power to the machine, so that the machine can take a decision similar to the decision taken by a human being. Okay, then the question comes that why do you need that this machine learning or deep learning algorithms at all, if the human being can do it, right. you think of a situation just before this I was talking about IoT, where I have huge amount of data, I can have huge amount of modalities, huge number of channels. For a human being, it is not at all convenient to keep all those channels, all those data in mind and take an appropriate decision. So, how the machine learning or deep learning helps is that when you have huge amount of data, the machine can process it further, the machine does not become tired. Say, I give you a simple example that I give you 500 pages of text and I ask you a task that in these 500 pages, you just try to find out how many occurrences of a word, say mother, exists, right? How many times the word mother appears in a document of 500 pages. Possibly, after going through 5 pages, you will start skipping occurrences of this particular word. It is because you get tired and it is due to fatigue that you are prone to make errors. But if I give the same task to a machine, the machine has learned that particular word mother and it goes on searching those 500 pages, the machine will do it much faster and the machine will not get tired. Of course, forgetting about the other aspect that if my computer becomes hot while working, definitely it will give you an erratic behavior, but otherwise it does not get tired. So, when you go for machine learning or deep learning, we want that the machine should perform the same way, take a decision in the same way as we human beings take, but it should do it much faster and in a more accurate way. But what it has to do, that we human being will dictate, right? The machine cannot dictate itself. Can I use CNN for 3D image reconstruction with scattered data from antennas? Yeah, it is possible, right. So, as I just said, we have not yet gone to that part of image synthesis where we use the generative model. So, as you can synthesize the 2-dimensional images, it is highly possible to synthesize 3D images as well from the scattered data. But I think I will not put it now, let us preserve it for future when you go for generative models and all. Is TensorFlow good to get starting for ML programming? Yeah, TensorFlow is actually one of the tools. You can use PyTorch as well, but TensorFlow, yeah, definitely it can be used. Yeah, there are more suggestions that use TensorFlow 2, right, and Coffee 2 is used for Cafe 2, not coffee, right. Cafe 2 is used for real time deep learning. If there is no need for data pre-processing in deep learning, how CNN or RNN are able to perform correctly? Yeah, this is the answer which I gave just few minutes ago, that the CNN actually performs the pre-processing task for feature extraction or feature vector extraction. So, it is not that pre-processing is not required. Pre-processing for feature vector extraction is very much needed, but that is done by CNN or RNN. How we are able to decide that we have to go for machine learning or deep learning? Okay. So, in case of deep learning, what you have is okay. Let me just ask you, when you talk about deep learning, what is meant by deep? What is deep in it? If you think of a multilayer perceptron, as we said that input to a multiplayer perceptron is the feature vectors which are computed by preprocessing techniques, right. In case of deep neural networks, we avoid that preprocessing tools, and the job of extraction of the features or the feature vectors is left to the machine itself, and that is what is done in convolution neural network part. Right. Now, it is the number of layers you have in the neural network that tells you what is the depth. So, deep learning comes from the depth, it is the number of layers. You have large number of layers in a deep neural network. So, how do you decide about the number of layers, or how do you decide the depth of your network? This actually depends upon the complexity of the data that you have. Okay. If your structure in the data is very, very complicated, you need large number of layers. If the data is very simple, then the number of layers may be smaller. So, when I was talking about a linear classifier, you find that if I have a problem where I can separate two different classes, separation between two different classes using a straight line or even a plane in multi-dimension, I do not need a large number of layers, less number of layers is sufficient. But if the boundary is not linear, depending upon the complexity of the boundary, we have to go for large number of layers. But there comes the question, it is actually a chicken and egg problem, right? How do you decide how many layers you have to use for solving a particular problem, right? And there is no thumb rule. You have to implement, you have to check the correctness or the accuracy you are getting. If the accuracy is not acceptable to the mark, you can increase the number of layers. So, there is no thumb rule to decide how many layers or what should be the depth of the network. Okay. So, it is exactly the same question, how to decide the number of hidden layers in neural network. So, this is what I have just answered while answering how we are able to decide that we have to go for machine learning or deep learning. So, these two are related questions. Is it possible to do ensemble of machine learning algorithm with some deep learning algorithm? In case of deep learning, it is usually not required because the deep learning or deep architectures is much more powerful and much more flexible, and here we have a single end-to-end solution, right? You feed the input and finally you get the output. So, ensemble mechanism is not really required in deep learning. Okay, I am learning Python in this semester in NPTEL. My next step is to go for machine learning of data science. Can you give me some suggestion for further step? I am in second year BTech. Right. So, as I suggested before, do not directly step onto deep learning boat. First, you go through say pattern recognition or traditional machine learning, then you go for deep learning. That will be better for you and easier for you. The next is what is gradient descent? What is the use of this algorithm? Right. See, gradient descent algorithm is something like this. I can think of an error function, error in classification or error in anything, right. When you try to solve it, our solution approach should be that I should modify my algorithm, I should modify my technique, so that the error is minimum. So, if I am at any arbitrary step point of time, I do not know whether my error is minimum or the error is maximum or error is somewhere in between. So, what I try to do is and the error value that I get, it is a function of certain parameters, right. So, when you think of this neural network, the weight vectors of this neural network are actually the parameters. If I change the weights, the error at the output will be different. If I change the weight in certain way, the error may increase. If I change the weights in some other way, the error may decrease. So, this is what is the gradient descent approach. That means, considering that error to be a surface, I have peak of this surface or the error is maximum, and I want to modify the weights in such a way that this error will be reduced. So, if I consider this as a surface, or say I am on the top of a hill and I want to go down the hill. So, this surface of the hill is actually my error surface, and at every point the error value is a function of the parameters which are nothing but the weight vectors. So, given an error function, what I have to do is I have to find out what is the gradient of that error function, right. So, if I modify my weight vectors in such a way that the gradient is positive, then that means I am climbing up my error surface, I am increasing the error. But if I take the gradient, if I modify the weight vectors in such a way that the gradient is negative, that means by modifying the parameters or the weight vectors in that direction, I am reducing the error. So, it is the direction of the gradient. If I move in the negative direction of the gradient, I actually reduce my error, and that is what is this gradient descent. You are descending along the surface, and obviously, the use of this algorithm, it is not only in machine learning, the same algorithm is used in any optimization problem, right. So, that whatever I have to optimize or a function that I have to minimize, you go for this gradient descent algorithm for minimization of the error function, right. How general DL architecture is different from medical ones, how to choose among. Yeah, this I think I have already answered before. Usually your architecture, deep learning architecture is more or less same, but it is the data set, and given the input, the output that you expect, those are different. So, what is different is even your training algorithm is also same, it is the same gradient descent algorithm, right. So, what is different is your input data and what you expect at the output, right. So, in some cases your application can be noise removal, in some cases your application can be say disease identification. So, depending upon that you have to set what output you want, and accordingly you have to define the error function, and the algorithm will reduce the error function. So, the architecture is mostly same, there is no much difference. How to choose transfer learning when medical image data set are different from general image classification as ImageNet. Okay. As we said that this transfer learning is actually for low level operations. So, you do not use transfer learning for high level understanding or classification. You use transfer learning in the convolution layers, because the low level features, whatever be the data set, is mostly same, right. Some layers extract the edges, some layers extract the corners, but their organizations and then final classification, that is what is done by higher layers or fully connected layers. There you do not use the transfer learning, right. So, transfer learning is used in the lower layers for feature extraction, and there whatever be your data set, it is highly useful. How CNN is impacting research on handcrafted features. I did not really get to the meaning of this question, but handcrafted features we talk about when we consider the traditional machine learning, right. You have handcrafted features, those handcrafted features are given to your machine learning algorithms for training as well as for testing purpose. But in case of CNN, we want that the CNN will extract the features. So, this pre-processing techniques for extraction of handcrafted features is actually replaced by the CNN layers, right. I think we have to stop, right. 4 more questions, 4 more minutes. Okay. Which one is better for human activity recognition, CNN or RNN? So, when you talk about human activity recognition, that means it is a sequence of events which actually define an activity. So, obviously, for human activity recognition, it is RNN that will be a better choice, but that does not mean that we cannot solve human activity recognition problem using CNN, because as I said before, that I can have sequence of frames, then you consider a video volume, because I have a number of frames together. So, it also captures the temporal information, right. So, that way CNN can be used on video volumes, right. So, time is up, I have to stop here now. Maybe the other questions you preserve for the next one. Okay. Thank you.